Hello everyone, my name is Viraj and today we'll be looking at the fourth problem from the CP-31 sheet by TLE Eliminators under the 900 rated questions. Let's go. So I'll be moving on to my CP-31 sheet over here, ticked off my 900 rated parameter, fourth problem, Jellyfish and Undertale. Let's read this. So Flowey has planted a bomb in Snowdon. The bomb has a timer that is set to B. Every second the timer will decrease by 1. When the timer reaches 0, the bomb will explode. To give the residents of Snowdon enough time to evacuate, you will need to delay the bomb from exploding for as long as possible. So it's a basic story that they are telling you and it makes sense, right? I have a bomb set to some timer B and it is going to explode. Alright, so you have n tools. Each tool can be used only at most once, alright? If you use the ith tool, the timer will increase by xi value, okay? However, if the timer is changed to an integer larger than a, then the timer will be set to a due to some bug. So they have mentioned all the points together. What is going to happen? You will choose possibly some or none of your tools that have not been used before. If you choose the ith tool, then the bomb's timer will be currently set to C and the timer will be changed to the minimum of C. Like if the timer is already set to C, then the timer will change to minimum of C plus xi, comma A. Alright, and then timer of course decreases by 1 every time, and if the timer reaches 0, then the bomb explodes. Alright, so now Jellyfish wants to know what is the maximum time in seconds until the bomb explodes if the tools are used optimally. Alright, so let us understand this problem. So we are of course talking about some variables over here. If you go back to the problem, it's a, b, n and then some xi value. So I'll just explain all that part. You have a as a variable. Alright, what does that denote? Then you have a b as a variable and n as a variable. So let's start with very basic. N is given as a variable. It basically means n tools. So you have some x1, x2, x3, so on value till xn. This is sort of an array you can say that is given to me. This is of n size. Now there's a bomb. I think I cannot draw the bomb, but you can understand that there is some bomb which is set with an initial value b as a timer. So there is basically a timer of bomb and it starts with b as its initial value. And then what is a? A is sort of a barrier or a bug that they have created. What are they saying is this bomb from b seconds, basically this can be termed as seconds, from b seconds of course is ticking, right? And how do you think a bomb will tick? It will go from b to b minus 1 to b minus 2, so it might reach 0. And of course, how normally it would make sense, if the bomb reaches 0, it will explode. So we don't want it to explode. We want maximum time we can find before I know the bomb is not going to explode. And to do that, I have been given some tools. This is this x1 to xn value. What are these tools? These tools are giving me the power to delay this explosion. I can say, okay, if let's say I use the tool x2, then what will happen is if let's say right now, b seconds after this has declared down to c seconds. Let's say the new value of the bomb on the timer is c. Then basically if you choose the second tool, your timer is going to get added extra seconds and it's going to go to c plus x2. Now this ideally should happen normally, but there is a small catch. This is where this a variable gets introduced. And what are they saying is that although you might have a large gap to jump and add your seconds on the timer, but you cannot go beyond a. So I will have to take minimum of whatever is this value, comma a. That means if c plus x2 gives me a value larger than a, then I will stick myself to a only and the timer is not going to show a value above a. This is a bug that they have reported. So all this story should make a lot of sense before you actually start the problem. So if you're not able to understand this by now, you should pause the video, maybe give the problem one more read, and then try to understand what is the significance and meaning behind each and every variable. So it's very clear in your head what picture are we trying to visualize over here. Once that is clear, what are they actually asking? So naturally, by simple means, they are trying to tell us, find the maximum seconds you can to defer the bomb from exploding or make the bomb not explode. That means I have these tools with me. I can use them however I want. And when I of course use them, I'm basically increasing the timer, right? If it's currently, let's say whatever some c value, then it's going to c plus x and maybe minimum of c plus x comma a. Then maybe it comes down, starts ticking. Maybe I use another tool and it goes back up and so on, so. So all this whole simulation that I'll do in my head, I want to finally get that maximum number of seconds. Target is maximum number of seconds I can get before bomb explodes. This is what I have to find. So use the tools however you want. Increase your timer, keep it decreasing by 111, and then maybe increase it again. Use some other tool, maybe use X1 tomorrow, maybe use X3 and so on. It doesn't matter. Whatever you do, eventually give me that final value where you think this is the highest amount of seconds I can make my bomb not explode. After that, it's no longer up to me. Whatever I do, the bomb has to explode. But before this amount of seconds, I know my bomb is not exploding. Find that value and report that as an answer. This is the problem. Let's actually see some test case and get a better picture of this. So let's say I have this test case 533117. So this is 5, 3, 3, and this is 117. So basically this is A, this is B, and this is N. So N is 3, hence you have 3 tools, and then A is 5, B is 3. That means the timer starts with 3 as a value. That is B, that's the initial value. And then A is that upper, you can say, bug that is there of 5 seconds. That is, it's not going to cross, or the timer cannot cross a value of 5 seconds. All right, great. So I can do a very simple thing over here. What I can do is, maybe I can leave the timer as it is, and I can be like, okay, timer goes from 3 to 2, and it goes to 1. Now when it goes to 1, I have basically covered, like you can say, I have covered 2 seconds, right? I have covered 2 seconds by which I have deferred the explosion. So I can count this 2 seconds gone. Great. Now what I can do is, maybe I can use the tool number 1 and tool number 2. If I use both these tools, remember in the problem, I could have used a single tool. Maybe it kind of gets stored in your head that we were only looking to store a single tool, but that's not the case. It's written I can choose some tools. So it's totally fine with me that I can choose 2 tools. I choose the first and second, and it increases my timer, right? It definitely increases my timer. This value jumps up and goes to 3 because 1 plus 2, that is 1 plus 1 over here, because I use the tools of 1 second and 1 second, I finally have 3 seconds. Now let's say I keep it ticking again. So it goes from 3 to 2, then to 1. So basically I cover 1 second more. And then what I can do is, I can maybe use the third tool. So ideally this value should jump to 1 plus 7, that is 8. But can it actually achieve a value 8? No. Why? Because A is 5, which is actually a, you can say, a bug. It's a boundary that if you're crossing it, oh no, go back to A. So this value doesn't become 8 actually, it becomes 5. Now from 5, I can have 5 to 4 to 3 to 1, and this is 1 second, 2 second, 3 second, 4 second, and then finally it goes to 0. So I can count this 1 second also, and when it reaches 0, finally it explodes. So if you add all these ones, small ones that I've drawn, you will find that this is actually 9. And this makes sense. This is the highest amount of deferring that I can do. And the argument is, if you even take some other road to find your answer, you will see that, yeah, 9 is something I cannot go above, and very clearly observable, 9 is the answer. So you can pause the video and run this simulation on the second case also, and you will quickly see why is 21 an answer. All right. So this is the whole problem. I hope the sample case and the whole structure is very, very clear. It's a complex problem. If you don't understand the variables, since there are a lot of variables, it's very important that you note everything down and you have a clear visualization of what does what mean. Great. Now let us move on to a very important discussion in this problem, that is the time complexity, since I can see that the constraints are pretty high. Alright, so what does that mean actually? So starting off with like very basic stuff, I have 1 second as 10 power 8 elementary operations. This is something that I know. In 1 second, I'm allowed 10 power 8 elementary operations. And this problem also allows actually 1 second for every test, right? So if I write that, okay, one test is allowing me basically 10 power 8 elementary operations only. That also makes sense. Great. But in one test, there are some test cases. This is by this variable t, which can go in 2000 order. So if I ask you what's the number of operations you can perform for every test case, this basically boils down to 10 power 8 upon 2000. Which gives you like 1 by 2 into 10 raised to 5. So this is like 0.5 into 10 raised to 5 or 5 into 10 raised to 4. So this is somewhat the number of operations you can actually do for every test case. Now, understand this over here that the complexities of B and A both are very high. Like the order you can say is 10 power 9, and n is actually small. It's kind of in 100 order. Now it would be good to assume that most problems are dependent on the n factor when it comes to this array and whatever part we take. So just to get a brief idea, maybe if we assume that we are having a time complexity dependent on n, then we have something like an order of 100 over here. So we are actually looking for orders. I'm not assuming or guaranteeing that our problem will have a time complexity only dependent on the n factor. Maybe I have some other factors also, but I'm looking for an order of 10 powers, highly what I can achieve. And in those terms, I can understand that, okay, O of n square, will this work? O of n square will work because 100 square will give me 10 power 4, and 10 power 4 is less than equal to this almost 5 into 10 power 4 operation. So it's going to work. That means above this, like n cube and all this part is not going to work. And if you go down, maybe O of n, so on to a constant time complexity, all of this is going to work. But this sort of creates an upper bound over here. Now this is very important. This is giving me the expected time complexity discussion. This is expected time complexity discussion. And this is telling me that, okay, don't create any ideas that run in n cube or higher order, or basically in this 10 power 6 order. Don't do that. If you do that, maybe your logic is right, but you will get a TLE. So remain in this n square boundary or this 10 power 4 boundary. That's good to go. And this is a rough approximation of time complexity. Maybe there are more factors that are involved, but generally assuming n is a good factor that might be involved in time complexity, I know I'm looking for a solution that runs below n square order, below or equal to n square order. All right, great. Now, once you have understood the time complexity, we can actually begin with the final observation in this problem. How do I approach this problem? All right, great. So in this problem, it obviously makes sense that I'm trying to simulate something. But when I talk about the complexities of A and B over here, they are very, very high. So imagine that I tell you, let's say B over here is 10 power 9. Let's say B was given to you as 10 power 9. Then can you try to think this part that you cannot actually simulate the problem? You cannot create a timer variable and think that, okay, I'll take this timer variable down to some specific value, and then I'll say, okay, now I am using a tool, then maybe do it again, and so on, because you know B is starting with 10 power 9 orders. So what if B was giving you 10 power 9? That would be a very high order to simulate. You will not be able to run a loop, you will not run any while logic, and that will not work. So ideally in this problem, we are looking for a smarter calculation. That would make sense. If we are looking for something very smart so that we are able to get answers quickly. And that is what is the crux behind the problem. So I'll present you an argument. The argument is actually answer to this problem is summation of I equals to 1 to n, minimum of xi comma a minus 1, and then plus b. This is actually the answer. Now, some parts of this answer would make sense as I have quoted right now, but let's try to deep dive into why is this answer correct and where is this coming from. I think I can break this down into two parts. This is like term 1 and this is like term 2. So term 1 is a bit complex to see. Let's discuss it later on. Let's look at simply term 2. Why this plus b? That is what I'm arguing in the total amount of seconds I can defer the bomb, b is a part. It makes sense. It should be a part. Why? Because initially your timer starts with b. So of course it has b value, then it will be b minus 1, then b minus 2, it's ticking, b minus 3, so on. It will go from 3 to 1, 0 and boom, it blasts. So this is going to happen. That means if let's say I ask you, you had no tools to start off with, what's the answer you would have reported? Of course, b seconds. That is the main amount of time your timer is ticking down from b to 0. So you know it's b seconds. But now you have tools with you. So this b seconds is going to be there eventually because that is finally when it reaches down to 0. But let's play a trick. Because I have tools in with me, I am powerful. I know I can do something. Maybe I can choose a location over here where I'll say, okay, this is a location where I want to use a tool. I'll say, okay, maybe somewhere like this. Let's say just call this location as C. In general terms, what I'm taking is in the problem also, so it makes sense. I'm just saying, okay, this is sort of a boundary C where I can place myself, and I'll say, okay, when it reaches or the timer becomes a C, you want to use a tool. So you have these tools x1, x2, x3, x4, so on till x5. Sorry, not x5, xn. Right. Now, what happens? Let's say you pick up some random tool. Let's say you pick up x3 only. So you go from C to C plus x3, right? So what happens is, like, if you were standing at this location, then this location, this location, this location, this location, so on, so on, so on. When you reach the boundary, you can say you jumped back again to some new location, which was even further on the left. And then again, you are ticking towards the right. This is of course happening. Now, when that is happening, there is a limit. There is some limit over here. It's like with the red pen I can draw. There's some limit like A. So when you actually take a jump, when you go over here, you cannot cross this. I mean, this is all the problem that we discussed up till here. Now the idea is, let's look over here. I have some sort of two cases I can draw. Let's say standing at the C location, you use a tool. Let's say this X tool or maybe like X3 tool, and you jump this much, but you remain in the boundary. So I can call this segment as X3 length. It would be very fine to say, yes, this segment is of X3 length. And let's say you take some other element, let's say, so I'll draw this over here. This is your case number 1, where you go from C plus X3. And then case number 2, where you go from, let's say, C to some other tool. Let's say you use the X5 tool, but X5 tool is very large. So you jumped a very large boundary, but you had to, like, because you jumped a very large boundary, you crossed this boundary A. So you had to stop over here. So now this segment length is kind of broken, and this segment can be called basically as A minus C. So what do I see? It's very simple. The blue area is the contribution a tool is making. This blue area is contribution to my answer a tool is making. And this contribution is actually minimum of whatever was that xi value, comma, A minus C. This should be very clear, because it's basically the minimum of whatever is these two blue segments that I drew. Either you segment is small enough so it remains within the A limit, or if it goes above A limit, then your contribution to the main answer is actually A minus C. That is this red portion after which is cutting off. So this is the segment that we are talking about, and this area doesn't get into picture. You say that, okay, this is not working for me. So when this idea is clear in our head, this contribution picture is clear in our head, now we know what are we finally looking at. We are looking that my answer, this answer is actually going to get added every time I use some xi tool. So if I say that your timer was some value, then it gets plus equal to minimum of xi comma A minus C added to it every time you use an xi tool. Use an xi tool. Sorry, use a xi tool. Now, tell me, you want to make your answer go as large as possible. So, this value xi is not in your hands. This value xi is basically every value that is given to you in the tool. This is an input that you are taking. So, whatever input is given to you, no control over this. This A value is also pretty much constant, so no control over this. It's basically given to you, so you cannot make it go anything. But this C value that you choose is a boundary, right? Remember, this is a random boundary we drew. Now, if I want to make my size go as large as possible, sorry, my minimum of this whole value go as large as possible, I obviously want to make sure that any variable that is in control with me is tuned to some value, which I think gives me the best answer. Tell me, if I make this C value go very low, very, very low, then what will happen? This value is, if C goes very low, then A minus C is going to go very high. And if this value goes very high, when I take minimum with this value in xi, of course it's bound to make this whole term go very high. This should be very clear. This is a simple mathematical notation that I'm talking about. And if this idea is clear, you can pause the video, take 2 minutes to yourself to understand this. If this idea is clear, then it makes sense that I should take C to be equal to 1. Why? Because I cannot take C to be 0. I cannot create a boundary at 0. Like if I say I'll create a boundary at this location, bomb has already exploded at 0, right? So it doesn't make sense. I want to choose that finite boundary, the smallest boundary where I think the bomb has not yet exploded. So can I say that this boundary is making sense? I should create a boundary at this location. So what I'll do is I'll create a boundary at this location. This becomes my C. That is why when I argued that the answer is minimum of xi comma A minus 1, This 1 is actually your C value. Now, the whole problem will get simulated like this, that you basically start off with the timer B, you go to 1 second, and then you use some tool. Let's say you use X1 tool. Then whatever increment that happens, and then you go back again, go to 1 again, same thing. You use some other tool X2, then you use some other tool X3, then you use some other tool X4, and you keep on doing this simulation of going to 1, coming back to some new tool, going to 1, coming back to some new tool. Happens, till you exhaust every tool, and then you finally jump this 1 second extra, and you are at a location where you have to explode. This is where you finally end the problem. This has fully utilized every tool, by the way, and it has drastically increased your answer to the highest capacity you could have had because you took everything into consideration. Now you can give the video, give the solution, a 2-minute thought, and you will understand this whole idea. Now, understand this, that since we discussed this in the very first part, I don't want to simulate this. I cannot go about a simulation. That's why mathematics. So, because the simulation was understood in my head, I found a mathematical formula out of it, and I noted it down in such a way that now what I have to calculate is not going to go in very high order. It's going to be very, very simple to calculate, and it's going to remain in my boundaries. Hence, this being the solution to the problem. Alright, so let's move on to the code part and understand how can we implement this. Very simple now. You take A, B, and N as input. You take the array input. And after that, like up till here, all I'm doing is taking inputs. Then the maximum time is a variable that I've taken over here. It of course starts with B. So that's the timer, maximum time, whatever you call this. And then you just add to it minimum of array of I comma A minus 1. That is that xi, you can say, or A minus 1, or maybe better we can name this X only so that it's clear, gives a clearer picture. Now you simply print out maximum time. This is the time you have deferred your bomb to explode in the highest way possible, and this is definitely your answer. If you run this passes all the sample cases and it's going to get you an accepted solution on the problem. Alright, and what's the time complexity? This is n order for the loop, and this is again n order for the calculation. Inside this minimum, all this part is pretty much constant. So I know I am getting a time complexity that is O of n order, which is O of you can say 100 order only. So our initial assumption was pretty much very appropriate. N was an order we were estimating, as in the n factor was something we were estimating, and it's there, no other thing is there, and we're getting an O of 100 solution. It's definitely going to work. It's within the 5 into 10 power 4 boundary of operations per test case. So this is good to go. What about space? Again, O of n only. I'm taking space for the size of the array, and this is O of 100. So definitely a very good problem, right? It requires this simulation in our head, and it should make sense. Why am I not simulating the bomb to go in actually this countdown sort of a timer? It's going to be drastically very huge for me to maintain that brute force solution. Not going to work. I need some simulation, some mathematics to actually get the whole answer running. If you understand the simulation, every variable is clear. This should be a very, very easy problem for you. Alright, so that's all. I hope you like the video. Thank you for watching.